Done now? Start.
Namaskar, Adab, Sat Sri Akal. How are you, students? I hope that you all are very good, doing very good. Okay. So, if I will talk about physics, we were in the topic electrostatics until where we have learned. We were understanding about the behaviors of dipoles. Okay, and we have founded the axial point, equatorial point, both electric field as well as potential. We have gone in the complete depth and we have seen step by step how to derive the things. Okay. So we have written and gone from the complete basics that I have tried to explain you completely that how much ways it is possible. Okay. Now we are going to understand a little bit more about this electric dipole, and then we will be entering into flux and Gauss law. That is our next portion. So we are here into the fifth lecture of electrostatics. Okay. So without wasting any time, let's start. Okay. Okay, fine, students. Let's begin. Last case, if I will revise, what was the electric field at the axial position? 2 kp divided by r cube. If I will ask you at the equatorial position, what was the formula? Kp divided by r cube. If I will ask you at the general position r comma theta, what was the formula? Kp divided by r cube root under 1 plus 3 cos square theta. If I will talk about potential at axial position, what was the potential? Kp divided by r square. At equatorial position, what was the potential? 0. At general position r comma theta, what was the potential? Kp cos theta divided by r square. So these many things that we have already studied. Now let's understand a little bit about how you will write. Our pen is back. Okay, that we are facing some problem in the last lecture. Okay, nice. I like green color, so let's continue with green. Electric dipole in an external electric field, let's suppose now you have applied. Now the question will be coming, what is the net force acting on the dipole? Let's suppose this kind of dipole is there. What is the dipole? Draw the diagram. Anyways, it is already drawn, but this negative to positive is always the direction for dipole. Now the question, if I will ask you, tell me what is the net force that is acting on this dipole? I will say, in an electric field, what is the force? Force is equal to Q into E, correct? And if this is a positive charge, it will be the same direction, that will be Q into E. And if it is a negative charge, again it should be a same direction, but because of negative charge, the direction will be reversed. And that's why I can say this will be my Q into E. So now, two force vectors are there on the dipole. If I will ask you, tell me what is the net force that is acting on this dipole, what you will say? One force vector in positive x direction, second force vector is in negative direction. That means what you can say about net force? Can you say net force is nothing but equal to 0? Correct. Net force is equal to 0. Correct now? My voice is clear? Correct. So let's see. And then now the next question. What will be the net torque? Does net torque also is equal to 0? No. Torque, where you have studied, students? Rotation. Rotation you have studied about torque. And what is the formula of torque? R cross F is called as torque cross product. Remember how to find the directions? Let's see how many of you remember. That is interesting. Now net force is equal to 0. That is very clear. Okay. But what about torque? Let's suppose, and anyways, this distance is, let's suppose, given as L, and this distance is given as L. That means net distance between them is given as 2A. Now, let's write torque about this hinge point. This is behaving like a hinge. What I will write? Torque. Okay. Torque due to net torque, I will write as torque due to positive charge plus torque due to negative charge. Okay. How I find the directions? R cos F. How we write? We write this is the line of action of force and this is the perpendicular distance. If this angle is theta, what you can say about this angle? This angle will also be theta, correct? If this is L, this distance is L, this one, this will be what? L cos theta. This distance will be what? This distance, if I am asking you, this will be what? L sine of theta, correct? And this is the line of action of force. So what you will write the net torque? You will write due to positive charge. What is the net torque? You will write L sine of theta into Q into E. And what will be the directions? According to you, what should be the directions? L R cross F. This is R. Show your palm to force R cross F. What is the direction that is coming? Inside the board. That means it is coming towards inside the board. Plus. Now what is the torque due to negative charge? This is the force that is acting. Now what are the two things that are required for torque? Line of action of force, and what is the perpendicular distance to that line of action of force. Now if this angle is theta, can I say this angle is also theta? This is L. What you write for this horizontal distance? This will L. This is theta. This will be L cos theta. This perpendicular distance, again L sin theta. That means what I can say about this distance? This is nothing but L sin of theta. L sin of theta, and this is the force. That means again we will say R cross F is nothing but L sin of theta into force, that is Q into E. Q into E. Now again what is the direction? Again do R cross F. R is in downward direction. Show your palm to your force. R cross, is it? Are you able to watch it properly? R cross F. That means can you say it is also inside the board? Inside the board. So can you say the sense of rotation for both the body, for both the charges is same? That is simply they will get add up. If you are adding, what I can say? I can say it is 2QEL sine of theta. Correct? Now what further I can say from here? What further conclusions I can write from here? Because 2L and Q. What is this? Charge into distance. Distance between both these charges is what? 2L. That means what is the net dipole moment will be what? P. That means what I can write also? PE sine of theta. PE sine of theta, students. That means what I can say also this as it is nothing but equal to P cross E. P cross E can also be written as torque. That means if I have to write a net torque, I can simply write P sine theta. Otherwise, I can write directly P cross E. That will be the result. Okay. Please remember the very important result. Now this one. Let's suppose if someone asking you at what angle it will be maximum, at what angle it will be minimum. Maximum torque will be applied when, and minimum torque will be applied when. Okay. So now what is the formula? PE sine of theta. PE sine of theta. Tell me, if I have to maximize torque, what is the value that I can change? I can control this angle theta, correct? So what is the maximum value of sine theta? You can say maximum value of sine theta can be set as what? Correct? Maximum value of sine theta is equal to, that means theta can be written as what? Pi by 2. That means torque will be maximum at what angle? At angle pi by 2. And if I will ask you minimum, when it will be minimum? Magnitude wise, maximum torque you can write directly P into E. Now if I will ask you, tell me minimum torque, what is the minimum value possible? Anyways you can say also that -1, but what I am saying, magnitude wise, minimum torque will negative sign will reflect to what? It is not clockwise direction, it is anti-clockwise direction, more or less. This is what you will do. But minimum can you say when it will become 0, the magnitude of torque will be 0. That means there is no torque that is acting. So at what angle it will be 0? Can you say at theta? If I am writing the condition for minimum torque, I can say sine theta have to be 0. That means I can say theta should be equal to either 0 degree or either 180 degree. That means 0, pi, 2 pi, this kind of values will be taken 0, and that means minimum torque I can say that will be equal to 0. And at what angles? 0 degree, 180 degree, whatever you want to say. Magnitude of torque is 0 or minimum when the dipole is aligned along the electric field direction, either 0 degree, either aligned like this, either aligned like this, either towards the electric field, either against the electric field. Both the side times angle will be either 0, either 180. Both the cases torque will be, net torque will be 0. This is the case for minimum and this is the case for maximum. Okay. Fine. Now let's discuss about little bit about energy. Okay. Energy. So till now what we know about that, how we have founded energy. If you remember, we say that work done by any force is converted into change in potential energy. Okay. So in linear world, how we write this work done? We write force into displacement. But in angular world, the same thing is written as work done can be written as U final minus U initial, that is equal to torque into d theta. Okay, torque into d theta. And torque into d theta at the place of F dot x. And now what is the thing that we are going to try? We want to change the angle of the dipole from initial angle theta 1 to final angle theta 2. from theta 1 to theta 2 we want to change the angle. So what will be the limits of integration? We want to change it from theta 1 to theta 2, correct? From theta 1 to theta 2. Okay, fine. So what we are going to do, and we want to check that how much energy is required for this thing. Okay. Now see, how will write torque? Torque is nothing but Pe sine of theta into d theta integration. Now further what you write, Pe will be taken out, integration will be left only for sine theta d theta. What is the integration of sine theta? It is nothing but, students, cos of theta. Cos of theta integration from theta 1 to theta 2, and the sign that will be coming outside is negative sign, correct? Now put the limits. When we will be putting limits, delta u can be written as simply Pe minus of Pe cos of theta 2 minus of cos of theta 1. Cos of theta 2 minus cos of theta 1. This is what delta u I can define. This is the change in, or the potential energy required to change the angle from theta 2 to theta 1. Okay. Now for defining, you remember for last case of potential energy we require some reference value also to define potential energy. So what is that reference value we are going to take? Correct. Now see, what is the reference value we are going to take? I will say what is my change in potential energy? It is equal to minus of Pe cos of theta 2 minus cos of theta 1. This is what the result that we have derived. Now what I will say that, let's suppose theta 1 is equal to pi by 2 and theta 2 is equal to theta, and theta 1 is the reference quantity I have taken. At theta 1 potential energy will be 0. Now put theta 1 here. You can see the statement also. We know that the potential energy or the change in potential energy is always measured from a reference position that we are trying to decide. We assume that the potential energy at the reference position to be 0. In this case, assume the reference position as theta is equal to pi by 2. We have assumed that theta is equal to pi by 2 is our reference. Okay. So put cos of pi by 2. Cos of pi by 2 is how much? 0. That means what I will write? Pe cos of theta minus cos of pi by 2. Cos of pi by 2 is nothing but 0. That means what is the potential that you are getting? Potential you will be getting minus Pe cos of theta. Students, tell me multiplication. This is what kind of product? Can you say it is dot product? That means it can also be written as minus of P dot E. This is the final result for potential energy that you have to remember. Either you can remember it as P cross E, either you can remember it as minus of P dot E. Minus of Pe cos theta, either minus of P dot E, both are the same things. That means the result for this will be always a scalar value. Okay. Now it will give you what? Energy. Now there will be two kind of cases. What are the two cases? I will say, tell me when the case will be for stable equilibrium. Stable equilibrium, when I will be having stable equilibrium. Now what is the case? Equilibrium means what? Firstly, understand about equilibrium. What is equilibrium? In Coulomb's law also I have told you about a variation of equilibrium. How many types of equilibrium I have told you there? Stable equilibrium, unstable equilibrium and neutral equilibrium. So here what I will tell you. Firstly, we want to understand stable equilibrium, and the property of stable equilibrium. Firstly, net force should be 0. Okay. Firstly, net force should be 0. Then net torque should be 0. Net torque should be 0. And the potential energy should be minimum. Potential energy should be minimum. Potential energy should be minimum. This is the condition for stable equilibrium. And what is the potential energy? Just you have seen minus of Pe cos of theta. If you want to make this potential energy minimum, what you can do? You can do that, make cos of theta as maximum. If you are maximizing this value and there is a negative sign, that means can you say you are minimizing this eventually? That is max. What is the maximum value of cos theta? Maximum value of cos theta is equal to 1. And at what degree it comes? At theta is equal to 0 it comes actually. So what I can say, potential energy, minimum potential energy will be minus of Pe. Minus of Pe. Here you can say, and this kind of equilibrium is called as what? stable equilibrium. So what will be the condition for unstable equilibrium? That also tell me. For condition of unstable equilibrium, for unstable equilibrium also, torque net is equal to 0, net force is equal to 0, but potential energy should be maximum. When potential energy will be maximum? When you are minimizing this cos of theta, because there is a negative sign also. Always remember, what is the minimum value of cos of theta? Cos of theta minimum value can be -1. What is the minimum value? Cos of theta -1. At what angle it comes? Theta is equal to 180 degree. That means what will be the value of potential energy maximum? In that case, potential energy will be plus of P into E. At what angle? Theta is equal to 180 degree. Okay. That will be the next case also. I will tell you. See. Unstable equilibrium, you can say potential energy is equal to P into E, and here you can see the direction. This is the direction for electric field, this is the direction for dipole. That means what is the angle between them? 180 degree, and that condition unstable equilibrium will be existing. Correct? I hope that this much of concepts are clear for you. So now we'll be entering into the new topic, that is flux. Flux is the new portion for electrostatics. Till now we have covered about dipole also. Now we will see flux. Okay. What is this flux? Flux is it defines the flow of any quantity through a cross-sectional area. If you will see the definition also, this definition says that. Okay. Before that, firstly understand about vectors. What are area vectors? Till now, I guess that it is very clear to you that area is a vector quantity. Then we will be coming to flux. Firstly, understand what is area. Area is a vector quantity. If I will explain you and how that area is a vector quantity, what will be the direction of that vector? That is also the case. Let's suppose this is a white sheet of paper. Okay, that is kept in front of you. This complete have some area. Obviously, the area will be there, length into breadth. If I will ask you do cross product of this length and the breadth, it will be coming the third, because you know cross product always gives a vector perpendicular to the plane. So when you are doing this cross product, you will have a vector of length into breadth. Some I cap J cap will be there. You will have always area vector perpendicular to this plane. I can say this is the pen that is showing. This is the area vector, and this area vector have the property that it will be always perpendicular to the plane. It is always perpendicular to the plane. Now see about the definition. Direction of area vector is always normal or perpendicular to the plane. It is a vector quantity. SI unit already you know, area is always meter square. Here for example, for the paper also, consider one area vector direction as positive and the opposite ones as negative. One direction, of course, because the perpendicular direction will be for both, outside the plane also, inside the plane also. So you can take anyone as positive, anyone as negative. Correct? Because if one is positive, other one will be negative. Here it is represented. Let's suppose it is explained x-axis, this is y-axis, this is z-axis, and a paper same as that. Let's suppose this paper is kept like this. This edge is what? X-axis. This edge is what? Y-axis. Correct? Now you want to calculate how you will be getting your area vector. What you will do? You will do I cross j. Now I think that all of you know about how to do cross product. Just take your fingers in the direction if you want to do I cross j. In general, I am telling you. What you will do? Take your hand in the direction of I. Take your hand in the direction of I and curl your fingers towards j. Curl your finger towards j. What is the direction that you are getting? Can I say it is nothing but equal to k? It is nothing but equal to k. What will be the area? This is 2 meter and this is also 2 meter. That means area magnitude wise it is 4 meter square and the direction will be k cap. That means net area vector, if I have to write, I will write 4k cap. Now why we are studying about it? Because actually it have a lot of impact in the Gauss law and the flux concept. Okay, that's why now please make sure you are remembering that area is not a scalar quantity, area is a vector quantity. Please remember this concept. Okay. Now see, there are some examples given. All the 2D surfaces are considered as open circuits. One is this concept, open surface and closed surface. All these are plane surfaces, open 2D surfaces. This circular shape, this rectangular shape, this is any random shape. All these are open surfaces and the area vector is also represented for them. This is the area vector for this one, this is the area vector for this one, this is also one area vector. Only one direction of area vector and an open surface is considered for particular problem. Okay. For any cases, we will be taking only one area vector, whatever it will be suitable. It is the transitions you are liking. Oh, okay, interesting. Now see, let's have some basic example. Okay, for area vector, what is the question? A square of side 5 meter, a square is there of side 5 meter is placed as shown, is placed like this. Find the area vector of the rectangle. Find the area vector. You have to calculate what is the area vector. Firstly, let's find area vector means how you will find a length into breadth. So firstly, we have to check what are the vectors. This is kept like this at some angle 37 from the x-axis. So what will be the points? This point is also mentioned for you. Now it will become very easy for you. This point is 4, 0, 3 and this point is 0, 5, 0. Now what you will write for AD vector? Let's write it. AD vector. AD vector. AD vector, can you say I is 0, K is 0? That means only J cap. That means what you will write? 5J. What you will write for AB vector? AB vector, what you will write this position vector? You will write 4I plus 3K. 4I plus 3K. Now if you have to find this area vector, what you will write? You will write AB vector cross AD vector. Or simultaneously you can do AD across AB also. Eventually you will be getting a negative sign, that is also fine. Okay. So what is your AB vector? AB vector, what you have written? Students, 4I plus 3K cross. AD vector, what you write? 5J. 5J you will write. Now solve it. What is the way of solving? Do you know? There is a trick, or I can say I always prefer this. Write I, J, K in this kind of rotational manner and then solve it. Now tell me, 4 into 5, 20. I cross J, what you will be getting? K cap. Okay, fine. Plus 3 into, it will be 15. K cross J, you are going in opposite manner of this rotation, so that means you will have a negative sign here. K cross J, it will be I cap. That means final answer that you will be getting minus of 15 I cap plus of 20 K cap. See, this is the final answer. This is your area vector that you are getting. So till now, I guess now you have sufficient feel that area is a vector quantity that always you have to take. Okay. So for 3D surfaces, how the area vector will be drawn? Again for 3D surfaces also, let's suppose I will take, if I had a box for you. Okay, I have stolen it from Shantanu sir. It is his machine box, but I have taken just for explanation purpose. Okay. So how you will define this in 3D? It is a 3D box. It is a, you can assume it as a square cubical box. So if I have to draw area vector, what will be the area vector on this plane? Perpendicular to this. If I will ask you area vector on this plane, it will be again perpendicular to this surface. If I will ask you area vector on this surface, this will be again perpendicular. So all the sides it will have different area vectors. All the faces will have different area vectors. Important is what? That it should be perpendicular. It should be always perpendicular, students. Okay. Now see, now come to flux that I was talking about. Flux already you have studied where, if I will remind you, you have studied about flux in the topic fluid mechanics. Okay, fluid mechanics, if I will tell you where, you remember that a rate of flow we have discussed Q. What is the rate of flow? Area into velocity, that you have created law of continuity equation. Correct? Continuity equation, how you have written? Area into velocity at that point that you have made is equal to constant, and everywhere you have equated. That is what the rate of flow of fluid. Okay, but flux is same for everything. Any quantity which is flowing through a cross sectional area, that is defined as flux. Here what we are going to study, we are going to see what is electric flux, that we are going to study here. Now what is electric flux? Let's see. Flux, it is a flow of quantity through a area normal to it. I have already told you it is a flow of a quantity. Okay, it gives you idea about the amount of energy crossing an area, or idea about the number of lines crossing an area normal to it. It will tell you that how much energy is flowing through the cross section area. It will tell you how many number of lines. Like in fluid mechanics also, we draw fluid lines there also. So here also we know electric field lines we are having. So how many electric lines or field lines will be flowing through it? We are going to judge that. Okay. For example, flux of a liquid, I have already told you, it was represented as Q, rate of flow. It was written as V into area. That means how much rate is flowing from here. Here velocity, same velocity is passing through all these three, and the areas are changing. So simply how will write define the flux for liquid, flux of liquid, you will write velocity into different areas that you are having. Okay. Now let's suppose the area cross sectional is somewhat like this. Okay. What will be the flux that is passing from here? Simply you will write what happened to it? What happened? I think again some glitch is coming. We have to take this pen. Okay, we'll manage from this pen. Correct. Now here what we'll write. This will be the velocity into area, that will be the flux passing through it. But what about here? Let's suppose now I have changed this area. If I will tell you in 3D how I can show. This was initial area and some flux is passing through it, some liquid is passing through it. Now but I have changed this as like this and I have some angle on it. Now what I will do, how I will write flux. Again I will write what is the net area. I will define a net area firstly. I will define a net area. I can say, what is this angle? This is what now my area vector, original area vector. But can I say it will not now? It is not the net area through which things are passing. I can say the net area through which liquid is passing is this area that I have shaded with red pen. Okay. So now, how I can define this angle will be theta. Correct. So tell me. If this angle is theta, what I can say, this angle will also be theta, correct? If this is A, what I can say about this component, this vertical component, what will be this component? Can you say this net area will be A cos of theta? This area will be what? A cos of theta? Or you can say vice versa also. Vice versa how? If this velocity is V, this velocity is also, here also velocity will be V. And what is this angle? This angle is theta. So along this area component, what is the component of velocity? Along this original area, the component of velocity is V cos of theta. So net what you are defining? You will be either defining V into A cos of theta, V into A cos of theta. Either you can do what? You can write V cos of theta into A. Both are same things. Now it depends on you what component you want to make. Both are interpreting the same meaning. That means we are calculating the net effective either area through which the thing is passing or liquid is passing, or either we will make the net effective component of the velocity along the net area that is present. Okay, this is the net area A, and what is the net velocity along that area? Just take it and multiply it. You will have your flux. Fine. Now see, for different things, now it is important for boards also. Here it is mentioned. Okay. So let's see what about we can understand from flux. These are some basic things. It is a measure of net electric lines of forces passing through a surface normal to it. Always find normal to it. That means through the cross sectional area that is perpendicular to the surface. Through that cross sectional area, how much electric lines of forces or electric field lines are passing, that is defined as electric flux. If I'll ask you about the SI unit, how you will write SI unit? It is represented as phi. It is represented as phi, and it is defined as E dot A. It is defined as E dot A. Like in liquid, how it is defined? Velocity into area. Here it is defined as, because here the liquid is not flowing. Here what is flowing? Electric field. So exactly same like situation. What I will do? I will multiply electric field magnitude and area, and when I will, let's suppose this is the area, which is very beautifully shown here. This is the area vector that you are having, and this is the electric field that you are having. What is the angle between them? Theta. So how you will define flux? Flux will be defined as E A cos of theta. So can I also say that as AE dot A? Can I say both are the same things? Either you are writing dot product, either you are writing EA cos theta, that is same. So if I'll ask you about the unit, how you will write it? You will write firstly the unit of electric field. What is the unit of electric field? Newton per coulomb into area. Area is what? Meter square. So this will be the unit that you can write. For non-uniform electric field, how you write flux? There will be E dot dA integration you will do, and that we also called as surface integration. But as of now, just understand integration of E dot dA will give you the flux for non-uniform bodies. Okay. Here three bodies are given. What you will write the electric flux passing through them? The first case phi 1. What you will write? E dot area 1. And what I can say, area vector is this, electric field is this. That means what is the angle theta between them? 0. If angle theta between them 0, that means cos of 0 is equal to 1. Correct? Cos of 0 is equal to 1. That means simply it will become A1. Here also I can say the same thing. This is the area vector. This same is the electric field vector. Again theta is equal to 0. If theta is equal to 0, cos of 0 is equal to 1. That means again I can write this as E into A2. Here what you will say, this is the line, and that means this is the kind of rod that is kept, and this is the area vector, this is the electric field vector. That is what is the angle between them? Theta is equal to 90. What is cos of 90? Cos of 90 is nothing but 0. That means the third case flux will be how much? 0. Simply. Correct? Is it clear? Fine. So let's move to the next one. Now let's calculate flux by yourself. Okay. Write a simple question. Firstly read the question. A square of side 5 meter is placed. A square of side 5 meter is placed like this. If electric lines of forces of strength, this much of electric lines of forces are there, passes through the square, then find the electric flux through it. Then find the electric flux through it. Can you say again it is firstly what you have to do, or either solve it, because it is the same kind of question that we have solved. Let's start solving. You have to calculate flux. Now this pen is also not coming now, but correct. Now let's try to solve it. Firstly define area vector. I will write area vector. Area vector will be simply AD cross AB, or AB cross AD, whatever you want to write. Let's do AB cross AB, because in the previous question also we have did same thing. AB cross AD. Tell me what is AB? AB, what do you write for AB? 3I plus of 4K cross AD. What is AD? AD is nothing but 5J. Correct? What you will write? 3 into 5, 15. I cross J, you will write K plus 20. What you will write further? You will write K cross J, you will write minus of I. That means what is the net value? You can write minus of 20 I plus of 15 K. Correct? This much you can write for area vector. Now how you will define flux? Flux you will define as E dot A. Now what is your electric field vector? It is 2I plus 4J plus of, sorry, it is not 4J, it is, we have to take the eraser. 2I plus of 3J plus of 4K dot product, then dot with what? Minus of 20I plus of 15K. Now what is the final result that is coming? It is coming 2I dot 20I. What you write? Minus of 40. Then J dot anything will become 0. That means finally you have to do simply this. 4K dot 15. It will be how much? Plus of 60. 60 minus 40. It will be eventually coming how much? It will be coming 20. So can you say this is my final answer? And the units are what? Newton meter square by coulomb. Correct? Is it clear? Any doubt in it? This way you will be calculating flux. Okay. So these is for open surfaces. Let's suppose if open 2D surfaces will be there, that's how you will be calculating flux. Okay. Now for any kind of curved surface, what you will do, the angle between the electric field and the area vector changes at every point on the surface. That means because area, if there is a curved surface, angle at every single point will be changing continuously. Due to that, what you have to do, you have to integrate it. How you will integrate? E dot dA. I have already told you, for non-uniform bodies you have to integration, you have to apply for curved surfaces because angles are changing at every single point. Okay. Now see, if I'll ask you to calculate flux through this body, what you will do? Interesting question. Firstly read the question. A cube of side L is placed as shown. A cube is placed somewhat like this. Okay. And the electric line of force strength is equal to, electric field is given like this, E naught I cap. I cap is the direction for this electric field, passes through a cube, then find the net electric flux through it. What will be the net electric flux that will be coming through it? Okay. Let's try to understand. Okay. Now you have placed a cube. Okay. Let's try one by one. Understand it completely. What is the direction of electric field? This is positive x direction. Area is clear. So these are 6 faces that you are having. This is surface 1, surface 2, surface 3, surface 4, surface 5, surface 6. All of you take a cube and try to visualize it according with me. Okay. Tell me about, let's start from surface 1. About surface 1, what will be the area vector? Can you say this will be the area vector? And this same is the direction for electric field. That means what you can say about theta? Can you say theta is nothing but 0 degree? Correct? Now tell me about this one. This is the direction for area vector. This is the direction for electric field. That means what will define theta here? Can you say theta will be defined as 180 degree? Okay. Tell me for S3. For S3, let's take a cube that I've taken from Shantanu sir. Okay. This is a kind of cube. This is the direction for electric field. Here, this is the direction for electric field. This is the direction for area. How much angle I have written? 180. This side, you will say area vector is also same. Electric field is also same. That means what is the net area between them? 0 degree that I have written. Now come to this surface S3. This is surface S3. This is the direction for electric field and this is the direction for area vector. What is the angle between them? Theta is equal to 90 degree. Correct? Now come to S5. S5, that means the area vector that is coming towards you. What will be? This is the area vector. This is the electric field. What is the angle between them again? Again it is 90. Downward side again can you say it will be 90 degree. And the inside, that the area vector that is coming towards me, this is the area vector and this is the direction for electric field. That means what is the angle between them? For S6 also theta is equal to 90 degree. Correct? Now I have mentioned the angles with all of them. Now how I will write? I will know that flux is what? E dot A. Flux is what? E dot A. And net flux, if I have to write phi net, I will write flux due to phase 1 plus flux due to phase 2 plus flux due to phase 3 plus flux due to phase 4 plus flux due to phase 5 plus flux due to phase 6. Now tell me what will be happening with flux due to phase 1. Phi 1, what you will write phi 1? Phi 1 will be what? E dot area into cos 0. Cos 0, 1. That means what you will simply write? You will write E into A. Forget about rest of the things. Flux 2, what you will write? Flux 2, this is surface 2. E dot A, that will be same, but cos of theta is equal to 180. That means can I say it will be minus sign? That means minus of E into A. Plus phi 3, phi 3, phi 4, phi 5, phi 6. All of them are at theta is equal to 90 degree. That means cos of theta is equal to 90. That means what you can say? Can you say all of them are nothing but 0? They are not contributing in flux because no flux is passing from these faces. And if now you will solve, what you will get? 0. That means what is the net flux passing through this cube is how much? 0. The net flux passing through this cube is 0. Okay, this is clear. So the answer that is coming will be quoted as 0. How we are getting? Is it clear? We have analyzed for every single phases. Okay. Now see for some closed surfaces, how you will be calculating flux. I have made it in a form of question, but it is a concept that you have to understand, and this is the starting of Gauss law. This is the base of Gauss law that I am telling you about. A charge q is placed inside a sphere of radius r as shown. Find the electric flux through the sphere due to this charge. How will write? Let's see. Where is the pen? A charge q is placed here. Okay. A charge q is placed, and what will be the complete flux due to through this sphere that you want to calculate? Tell me what will be the electric field lines that will be flowing through this. It is, let's suppose, a positive charge. That means electric field lines will be coming after this. We have seen in the electric lines of field properties how this electric lines of forces we are drawing, correct? And now if I will take any cross sectional area, let's suppose this is dA, this is dA surface. What will be the direction for area vector? Can you say area vector will also be same? This is dA vector, area vector. If I am talking about this position, this is my direction for electric field radially outward, and this is also the area vector that is radially outward. If I am talking about this position, can you say area vector is again the same direction? That means one thing I am very clear, that if I am writing this d phi small flux through any element, let's suppose this element I have taken, what I will write? I will write E dot dA cos of what? At every place's angle between them is equal to theta is equal to how much? 0 degree. That means cos of 0. That is sorted. Now what I have to do? I will simply write E dot dA integration. dA integration means area integration. Electric field is common. At all these points, electric field, how you will define? Electric field at a distance r due to a point charge. What is the formula? KQ divided by r square. Simply write KQ divided by r square. Integration of dA. Now what I am trying to integrate, please understand that also. I am trying to integrate all this dA, small surfaces, all I am adding, and then I will calculate the net flux through this method. So that means I am trying to calculate the total surface area of the sphere. It is a sphere, it is not a circle, it is a sphere. So tell me what is the total surface area of a sphere? Can you say 4 pi r square? Correct. So what I will write? KQ divided by r square was already there, and integration summation of this dA will give you total surface area that will be equal to 4 pi r square. Now what will happen? R square simply will get cancel out, and a very important result will be coming here. Please listen carefully. What happened? A very important result will be coming here. 1 by 4 pi epsilon naught into q into 4 pi. This 4 pi will cancel out, and what will be left here? Flux will be written as q into epsilon naught. This q divided by epsilon naught is actually a very important result of Gauss law. This is the foundation of actually Gauss law that I am telling you about. Okay, Gauss law states that the net electric flux through a closed body will always be equal to the net charge that is present inside that surface divided by epsilon naught. Now I will tell you one more very interesting thing. You have calculated for sphere, but what if I will tell you this actually doesn't depend on the sphere? See, is there any radius term is here? Is there any radius term, any length or anything? This is only result. This result is only what? Q divided by epsilon naught. There is no term for this area or this kind of things. Correct? That is the best part of this derivation that you will see. That finally, after deriving everything, you are not having any kind of term. Very better way explained here. For all these cases, 4 different cases we have taken. Let's suppose flux, 2 charges are kept. To any random surface I have taken Q1 and Q2. What will be the net flux I will write? Net flux will be written as net charge inside Qn divided by epsilon naught. What is the net charge present? Q1 plus Q2 divided by epsilon naught. Second case, different sizes I have taken of same shape. This is one circle sphere, or this is bigger sphere, but doesn't depend whatever kind of sphere, bigger or smaller you are taking. Only charge that you are taking inside is Q. That means net flux will be simply Q divided by epsilon. It doesn't matter 10 spheres you are taking, 10,000 spheres you are taking, or 10 lakh spheres you are taking, doesn't matter. Different closed shapes. Now here I have changed the shapes also, circle or spherical, cubical, cylindrical, everything I have taken. Still the flux will be how much? Q divided by epsilon naught. Let's change the charge place anywhere. Let's suppose I want to keep it here. Until unless it is inside that shape, there is no difference on it. Still the electric flux will be what? Q divided by epsilon naught. This is a very good result actually, if I will tell you, correct? Because it is not depending on the surface, what kind of shape you are taking, size you are taking. Only thing it depends, it should be inside your closed surface. Okay. So what is the result that we are getting in general? If I have to say, in general, if we have to write, if when a charge is inside a closed surface, simply a charge is there, this is a surface. Actually we define this surface further as Gaussian surface. I will write net charge is equal to Q divided by epsilon naught. Actually the flux, net flux is equal to Q divided by epsilon naught. But when the same charge is present outside, the net flux that I will be writing, that will be equal to 0. Because until unless it is not present inside, I will not going to define it as it will not be counted as flux. Okay. It is mandatory, only single condition, that it should be present inside the surface or inside the body, closed body that you are taking. Okay. Now this is the statement for Gauss law. What is the statement? Let's read it once also. Statement is what? The total electric flux out of a closed surface is equal to the charge enclosed divided by the permittivity. Exactly the thing that we are writing. The net flux, total flux through a closed surface is equal to net charge divided by the permittivity by epsilon naught. Already we have seen net flux is equal to Q divided by epsilon naught. If you want to derive it, how you will derive? We have taken some charges here for board purpose. I am telling you, otherwise result is already we have derived. Some charges we have taken: Q1, Q3, Q2, Q5 and Q4. It will have some their electric fields. It is having, all those are having electric field that is in opposite direction. Okay. So what you will write? The flux, net flux. I will write the net electric field into area. Net electric field into area. I'll write the net electric field. You will be writing what? E1 into dA, because the area is same, plus integration E2 into dA plus integration E3 into dA. How many charges are there? Same you write for E4 into dA plus of integration E5 into dA. Correct? And what is E dot dA? Already we have seen it is nothing but equal to Q divided by epsilon naught. Correct? That means if I will ask you what will be the net, if I'll ask you what is E1 dot dA, can you say it is equal to Q1 divided by epsilon naught plus E2 dot dA. This is charge 2, that means it will be equal to Q2 divided by epsilon naught. E3 dot dA, E3 dot dA, E3 dot dA, what you write? Q3 divided by epsilon naught plus E4 dot dA, E4 dot dA, E4. Q4 is what? Outside. Outside the surface, what will be the flux you will write? 0. E5 dot dA, E5 dot dA, again you will write 0. That means the net flux that you are going to write, will be equal to Q1 plus Q2 plus Q3 divided by epsilon naught, or in general I can also write this as Q net, that is placed inside, divided by what? Epsilon naught. That is the derivation part. If you want to check, you can write like this. You will have because in the board exam all of you know about this thing, but still you have to prove that. So in this way you can do that also. So this is about flux. This is the same thing. So finally you can write as it as E dot E net into dA. This is one form. Other form will be Q in the net charge that is present inside divided by epsilon naught. Okay. If I will talk about a basic example, you have to calculate what is the flux, net flux passing through these three different kind of bodies are given to you. Three different kind of bodies. What is the first body? It is an open hemisphere. Second one, charge is placed inside a closed hemisphere. Third case, charge is placed outside the closed hemisphere. These two are closed. This one is open surface. Now see how we calculate flux. Tell me, what if I will add a similar hemisphere from downside also? What will happen? Now can you say it is a closed surface? Can I say correct now? Now if it was a hemispherical ball and from downside also I bring one more hemispherical ball. Now I can say it is a closed surface. That means what I can say, due to two hemisphere, what is the net flux? Now if this is a complete circle, what you will write the net flux? Q that is present inside divided by what? Divided by epsilon naught. But the question is actually asking you for one hemisphere. That means for one hemisphere, what is the net flux? You will write Q divided by 2 epsilon naught. This way we write flux. Second case, it is already closed. That means there is no problem. If this is closed surface, simply what you will write? Q divided by epsilon naught. No problem. Here what you will write? It is a closed surface, but the charge is not present inside the surface. That means net flux you will write how much? Net flux you will write it is nothing but equal to 0. It will be equal to 0 because it is mandatory for the charge to be present inside the closed surface. Even if it is closed or open, doesn't matter. It is mandatory to be present inside. See here, what I did, I have placed one more hemispherical ball from downside. Now it becomes a closed surface, but due to two surfaces, we will be having flux Q divided by epsilon naught. For one surface, what you will be having? Q divided by 2 epsilon naught. For second case, again it is complete theoretically. It is written here. These theories that is given that are very important for you. It will be helping you a lot in the board exam because you will be knowing the answers. But directly writing 0 Q by epsilon naught to Q by 2 epsilon naught, this is not going to help you. In the final exam, you have to write mention the complete process that how you are getting, what are the statements that you are writing. These will bring you good marks. Let's solve this final question also. Read the question. A charge Q is placed at a distance a by 2 above the center of the horizontal square surface of HA as shown. Find the electric flux through the square surface. A cube is taken and it is kept at a distance a by 2 from this face. You have to tell me what will be the electric flux through this base bottom. Through this, what is the electric flux that you will be getting? Like if I will tell you, this is a cubical block, and I want to calculate, and I have put it, I have opened it, and I put it a charge inside, and I want to see what will be the net flux that will be coming out of this base. So let's see how we will do. If I'll ask you, tell me, net flux through the total cube will be how much? Net flux through the total cube. Cube will be through the cube. It will be net charge present inside cube divided by epsilon naught. Now, how many faces this cube have? That means I can also write the same thing, that 6 faces are giving you how much flux? Q divided by epsilon naught. So if I'll ask you about one face, because everything is symmetric, due to one face how much flux will be coming? It will be simply Q divided by 6 epsilon naught. It will be Q divided by 6 epsilon naught. This will be simply what I am writing, due to the flux through this square cubical body, and through the cubical body Q divided by epsilon naught. But due to, if I am asking you about one face, you will write what? Q divided by 6 epsilon naught, because 6 faces are giving you Q divided by epsilon naught. That means one face will give you how much? Q divided by 6 epsilon naught. I hope that it is clear, and this is it for this lecture. So I hope that all of the concepts now you are feeling comfortable with. Okay, so now just like this, keep working hard for your final goal that you are having. Okay, and endigo and then digo nama tapasya. Keep learning, keep growing with tapasya.